Hello! In this video we're going to talk about a very simple architecture of RESTful API application. Basically we're going to create a block and get that block. So I'm not really going to just do the code in these lambdas because they are too much details, but what we are really going to do is to put the architecture and put this system together. Just make sure it works locally. We can test everything locally, and then the rest would be detail. And in a nutshell, we have a client sending a request to an API. We are going to use API gateway because it's from AWS, and then from the depends on the route, it's going to be trigger a lambda basically. So in a normal scenarios, you need to really create your code and then send it and deploy it to the AWS, then you can test it. But what we are going to do here is to just test everything locally and really mock the whole scenario and orchestrate the whole things locally, test everything locally, debug everything locally, make sure everything works fine. So you don't have to deploy all the time and then test your code. So you can just do everything locally. And as I said, it could be many more lambdas, it could be many more routes, but we're going to just really check with bare minimum. We're not going to do anything with DynamoDB in this video. I just put it here for the sake of argument, because usually with your lambda, you're going to do something. What we are going to do here is just receive API gateway request, go to the lambda, do something, and then really a very bare minimum things, and then return the response. We don't have to really in this video go and deep dive into DynamoDB and other things because this is totally a different topic, but all I'm trying to really show here is the orchestration within the project that you can see in front of you, API gateway and lambda, because not every lambda go to DynamoDB. It can do different things. It doesn't have to really be a database. It could do many other things, but just for the sake of argument, you're sending a request, your request will go to a lambda, and the lambda will do something. Now that you are aware of what is happening with the architecture, let's go and talk about what do we need to do before diving to the code. First thing first, you need to install Make. Make is basically going to give you some facilities to run some commands. That's it. It's easy to install. If you're using Mac OS, this is how you're doing it. And if you're going to use Windows or Linux, that should be pretty much the same thing. All you have to do, just look into how to install Make, and then you can follow it. Make is basically not necessary in this case. We're just using this one to run some commands and just making it easier to package and really just put some commands together. You can use package.json, or you can use any other things to run some commands. You can use terminal if you want. It's totally up to you, but we're going to use Make. Next thing you need, obviously, because we said we're going to use serverless framework, so you just need to install serverless framework. Serverless framework is required for this tutorial, and all you have to do is just to install it globally. And to install globally, all you need is npm install -g serverless. And as you know, if you need npm, then it means you should have installed Node.js beforehand. So if you don't have it, just go and grab Node.js, because we need Node.js, and then you can have serverless. And then once you have the serverless, we need serverless-offline to test everything locally. So now, to begin with, we have a serverless YAML file, which is empty. There is nothing in it. And there is Go module file. So if you want to create a module, all you have to do is to just say Go mod, and then init, and then just the package address. So, or the module address. So I will go back because we already have the Go module. The next thing we need is to have serverless offline. Because we need serverless offline, it means it's an npm package, so we need npm or package.json. So we have this one, and then we are going to install serverless offline as a dev dependency. So npm install -d serverless offline. Good. So we have the serverless offline. Let's just move on and create some stuff. From this point, we don't really need to know anything about Node.js because we are purely going to use GoLang for this. tutorial. So I'm going to close this one. We don't need the Go mod. I'm going to close it. Serverless YAML file is the main one which we need at the moment. So with the serverless YAML file, we need to do a few quick things. So what we're going to say, so we need a service, which our service could be anything. Let's just give it exactly the same of our, well, what do we have here? Just the folder name. So I'm going to just give it a name. And then I'm going to use framework version, which is going to be anything bigger than 3. So if you just look at serverless, because as I said, you have to install it globally. If you look at the serverless, so you should be able to see the version we have installed. So we are running at 3.24.1, but really what we need is literally any version bigger than 3.22. So I will just stick with this one. And then we have installed a plugin. Our plugin was serverless-offline. So let's just add it there. So our plugin would be serverless-offline. And well, it doesn't really matter, but in this case, we're going to use AWS just as a provider to run everything locally. You can use anything else, but let's just give it a provider. The name would be AWS. Runtime would be Go version 1x, and stage would be local. So we have the provider, we have plugin. Let's just quickly go and add some configuration for the serverless-offline. Basically, all we're really going to do, we put it in a custom, and with a custom, we're going to add some configuration for serverless-offline. And we are not going to prepend the stage in the URL. Basically, what it means is when we're going to run the server locally, it's not going to prepend it or put the prefix local to the service. And then the next thing is to add our functions. Functions are, in this case, are lambdas. So we are going to create a function called ping. There is a handler. The handler would be, this is the address to the handler. And what is the package? So this is the package, and it's going to be, the path would be /ping, and the method would be get. How are we going to achieve it? Now we're going to write the code very quickly and see what does it look like. How I'm going to put the structure on the directory and everything is just totally my preferences. You can do whatever you want, but let's see how we can achieve it. So all we have to do is I'm going to just create a directory. So mkdir, and I'm going to call it basically functions. Good. Inside the functions, now I'm going to create another function, or I can just do it from here, and I'm going to call it exactly ping. And inside ping, I'm going to create a file called main.go. So now we're going to write our GoLang code. The package would be like always, package would be main. And what we need to do, we just need a few quick things to just sort out. So we need a function called handler. It could be anything, it doesn't matter. So I'm going to call it handler, and then from handler, it's going to do some stuff. Let's just keep it at the moment as it is. We're going to come back to it. And then last but not least, we're going to have the main func. So just main, and then all it does, it's going to start the lambda. So before going there, we need to just add a package. Go get github.com/aws/aws lambda go. So we're gonna just add this one to our package. Now that we have this one, so if you go to Go mod, you can see we have the AWS lambda. So now we can use it quickly here. So basically from here, I should be able to use lambda, then start, and then I'm going to just give it the handler function. So let's just now update our handler function. Our handler function will receive a request, which is API gateway request. So I'm going to paste it here very quickly. And the moment I save it, I'm going to get the lambda and then the import, and then the output of the function would be either the API gateway proxy response or the error. But just before moving there, very quickly, I'm going to create a type because I'm going to use the type quite a few places. So the type is response, and basically what we are going to do here would be just returning response and error. So far everything is good. The next thing that I want to do is just really to return something, because this is a ping and it's going to give me pong if everything goes well. So let's just return response body will be basically pong, and the status code which you are going to send would be 200 in this case. So I'm going to just say status code will be http and dot status. Okay. So this is the simplest thing we can do. Basically, we want to check if everything is fine in our Lambda. If it is, then good. If not, then it should throw some errors. We don't really want to do anything more than this, but we're going to keep it like this. And the second argument, which is error, we're just returning nil, because I don't think anything can go wrong here at this stage, because we don't really do anything at all. We're just really returning pong. And the next thing we can do, we can just create our makefile and then update the makefile very quickly. So let's just quickly create makefile. So makefile should be exactly like this. And then inside the makefile, very quickly, we are going to just have some commands. What we really want to do is we want to build the ping and then use it in our serverless. So if you remember, in a serverless, we want everything in a bin directory. So in order to do that, we have a few solutions. Either we can just use terminal to do everything. So it's very simple. In order to do it, basically, we're going to just set some environments. So we're going to use AMD64 and then Linux, and then we're going to build. We will give it some flags, and then the output will be in the ping, and then it's going to read everything from functions /ping /main.go. So it's functions ping main.go, and let me just press enter. Basically, if you just want to repeat yourself and all the time put everything in a terminal, be my guest. But as your project will grow and you will have more lambdas, or you need to do more stuff, then it's easier to really just put all your commands into one file and then run them as with one command. Makefile make it very easy. One thing we need to do is basically to just give a label to our command. So our command is build, and then what we are going to build, very simple. Now if you're going to run it, we're going to get the same output. So let's just say make and then build. Okay, now we're gonna get errors. If you see these errors, basically what it means is because the file name is wrong. So all I have to do is just to give it a proper name. So F should be small. The only capital letter is M, makefile. So now I'm gonna run it, and let's see what would I get this time. Okay, every time, and this time everything goes well. So to prove it, we can just create another command to clean the whole things. So let's just do it now again. So I'm going to just call clean, and inside clean just put a bit of space, and I'm going to just do go clean, and then also I'm going to remove basically the bin directory. So then /bin, and then if we have other stuff we can just remove it, but at the moment I don't have anything else to remove. So I'm going to remove the bin directory, and before every build we can also run the clean. So why not to do it? So I am going to clean something, whatever is the clean, and then run the whatever command I have here. And if I want to make it silent, I just need to put @ before them, so it doesn't really show anything on the output. So I'm going to just say now go. As you can see, if I say, sorry, not go, make clean, now we don't have the bin directory. So now all I have to do is say is make build. It's trying to clean and it's trying to create or build the file. Good. So we have the ping and we have serverless.yaml file. Let's go and test everything now in a second. So in order to run everything, again, it's very simple. We can just do it in package.json or we can use makefile. It doesn't matter. So let's test everything by saying, for example, start. I'm going to give it a command called start, and inside start, I'm going to say SLS offline, because we have serverless offline. It's going to pick up the whole things. And then let's just give it a use Docker, and then we're going to say start on the host, which is 0.0.0. Okay, now let's just do this one. So we build everything we just did here, and what we're going to do here is make start. It's going to start the serverless offline for us. Now we have API and a lambda, API gateway and a lambda, and we're going to test it together. So I'm going to just drag the postman to the screen, and I'm going to the port 3000, which is a default port for serverless offline. You can change it. So, and then I'm going to send the request. Okay, as you can see now, we're going to get pong and everything is running. I just was getting timeout for a few seconds. I don't know why, but eventually now I get the pong. So if I do ping, I get pong. Everything is good now. So I'll stop the server, Command C. I don't need it because it's using Docker. Probably I was getting some errors, which I need to find out. Now we have one very simple lambda, and we can just run some, just really returning pong. It doesn't do anything more than this. Let's just add a few more functions and see how it works. So going back to the serverless YAML file, again, we are going to add a handler for a function called blog get, and we're going to have another one for blog create. So I'm going to quickly paste the code I have here. So blog get, just put a bit of a space, blog get, it has a handler called, which is the handler is in the bin again. And again, the path would be /blog/ just any name. The method would be get. We have the course enabled, and the path parameter, we will have a name, and we have query string, which is active. So we will create one more lambda or function, which is again creating a blog, and then it will be post method, and the path would be /post. So what we have to do, we just need to do the same thing exactly for which we did for ping. So we're going to create one lambda specifically for get blog and one lambda for create blog. So basically, if we go to the blog-get, we have a main file, and inside the main file, we're pretty much doing the same thing. But now I'm checking for the path parameter, whatever is the name, I just put it in the variable called name, and then I'm reading the query string active and then put it in the variable. And then basically what I am doing is just parsing the boolean from the string. So I want to make sure whatever they pass as active, just want to convert it to boolean. And then I am going to create a struct from name and active, and then basically marshal it as a JSON and moving on. This time, basically the difference is, obviously you can see we have blog.response is a struct. We just really, the output would be JSON this type. You can call, as you know, the JSON file anything, and even though it's called active, we can just say show. So let's just pass it this way, moving on. So the output will be show, moving on. Again, we're just changing the header to application/JSON. Again, status code would be okay. The rest would be really exactly the same thing we were talking about. On the blog create, exactly the same thing. We're not really going to create it because, again, this is too much details. Whatever you want to do in your Lambda, you can do it. But all I'm trying to do is to teach you how you can orchestrate and just put all of these things together and run your Lambda with API gateway locally. So basically the status code would be 201, it would be JSON, and just for the peace of mind, what I am doing is whatever you send as a request, I will just pass it to the body as a response. So nothing very fancy here, just everything will be just repeated basically. Next thing we need to do is to update makefile, because now we have more files. Now you will see why it makes sense to have a makefile, because what we want to do is to do the same thing for the build, for example, create, get, and if you have more lambdas, you will have more stuff to do. So what I'm going to do again is to just copy and paste, put them all here, and everything is good to go. Now we have a clean, which cleaning for us, build, which is really clean, and then build. For the start, we can do the same thing. What we have to do, we just want to say before any start, I want to do the build and then start the serverless offline. And next thing that you shouldn't forget is basically if you're going to deploy your code, you need to make everything zip. And just because if you're going to deploy your lambdas, they should be in a zip format. And again, it's very simple. You can just build everything. Basically, we don't need to clean, or maybe we will clean. So you're going to build everything, make everything zip, and then deploy everything with serverless. Again, nothing very fancy. You can do pretty much a lot of things here. If you really want to, for example, format your code, again, instead of remembering everything all the time, it's just as simple as creating a format command, and whatever is going to run would be similar to this. So if I say make format, it will going to run whatever command I have and does it for me. So now I'm going to do make, one more time, build. You can see it should delete everything and now add everything back in. Good. Let's run our project one more time locally. So make, and then the command here is start. It's going to clean, build, and then run it locally for us. So now I'm going to run the ping and blog and create blog and see what would I get. Because just, well, let's test it and see. So I will press ping and I am getting timeout because of basically, as you remember here in the makefile, we are using Docker to run the serverless offline. So if the Docker is not, the image is not, or the container is not up and running, we're gonna get timeout. So if you go to your Docker desktop, all you have to do, just start your Lambda, and then you are going to get the result very quickly. I'm only seeing this problem at the moment with the current version of serverless offline. So you don't really get it with the previous versions that often, at least as far as I remember. And also I'm only seeing this problem with the Go. I don't know why we're getting this error at the moment. As I said, all you have to do, just start your containers and everything should be fine. But you don't get it with other versions or other languages. Definitely you don't get it with the Node.js. I only see it with the GoLang. I don't know why, but just the trick is basically to run your run your containers here, and then now if you just do ping, you should get the pong very quickly. And then if you go to the get blog, which is, this is the name, and this is this query string, you should get them here as well. So let's just run it again. There we go, you're getting it. And then if I change it to, I don't know, demo, that's the name of blog, you should get this one as well. The reason that it's active and here is show, it's very simple. If you remember, in a get blog, we just actually cast it or change it to, when we are just parse it to JSON, we are just change it to show. It could be anything, we just changing it to show. you can just rename it to whatever you want. And then if we go to create, then you are going to, if you remember, we were just passing whatever is the request to body. So if we create it, we are getting it here again. So this is it, my friends. You now are testing the full end-to-end flow of your serverless application locally without needing deploying the code to cloud and just then testing it. And it's very simple, it's very easy. So in the serverless file, all you have to do is just to add the plugin serverless-offline and then choose your runtime. And if you want to add any configuration to the serverless-offline plugin, this is the place you can do. So you can add it here, or as you can see, we're just adding some of them as well here. Long story short, you are going to achieve the exact behavior of what you're going to get on the cloud here locally on your machine. So it's very simple, convenient, and then it will give you like a lot of opportunities to run your test, end-to-end test, or run your basically code locally and just debug it, because it's much easier. One more thing that I need to mention is I only see this error, which is a timeout. Well, it will just time out a few times and then it will work. At the moment with this version of serverless-offline, hopefully in the newer versions this one will be fixed. And also I only see it with the GoLang, I don't see it with the Node.js. Definitely I've tested, there is no issue. Probably there is something when we're running it in a Docker, but the answer to that one, or the trick, is really to just come here and start the container from your Docker dashboard or from terminal, and everything should be fine. Thank you so much again for watching this video. If you learned something, please don't forget to like or subscribe and share the video with some of your friends and colleagues if they're going to benefit from this video. Thank you, and I'll see you in the next video.